Hello. Sorry, guys. I just had a small power disruption. Uh, it's back again. Can you hear me now? Just please checking on and confirming on the audios and the visuals. I'll share the PPT again. We were on this one, right? Okay. Thank you. Okay. So this was the first one. So the logic is, in order to minimize on your calculation, okay, always first have a look at the options. You just see what is your denominator that is being expressed to even after all the cancellations. So take the the LCM of all of them. First of all, you can eliminate, like, expecting, at least estimating whether the answer should be less than one or more than one. Like here in this case, we eliminated first because the answer cannot be greater than one, and then later on we worked on, on the denominators where 64 would be the ideal number to take with, right? And hence then after that you can just take 64 as the total value and then solve it out. Okay, so that was D turning out to be the answer in the end, right? Okay, now let's move on to the next question. There's a comparison one. Just check this quickly. This is the easy one, very straightforward. What should be your answer? Check this one. Why C? Why do you think it will always be equal? A would be bigger. So if your x and y are positive number, so let's say if x, you know, let's take x is 5, y is 10, then x by y is 1 is to 2, this is 1 is to 4. This is greater, right? If x is 0.5, y is 0.1, right? This is 5 is to 1, okay? Or this is, let's say, zero point 0.5, and this is y is point, you know, also zero point 0.5. Take them equal. So you have 1 is to 1. This will also be 1 is to 1 where they can be equal, right? So therefore has to be D, right? They can also be equal, right? There's nothing, though we're given that x and y are distinct. So if they are equal, the ratios can also be equal, right? So that's the reason you can eliminate them quickly, right? Perfect. All right, D is the answer. Let's check the other. Can we say the same thing on the similar lines? D again, right? Perfect. Okay. So x and y are positive numbers, so we can take x as 3, y as 4. This is 3 by 4. This is 4 by 5. This is bigger. Okay. You can take minus 3 and 4 because, okay, they are positive numbers. Okay, so you can take 4 by 3 and then the other way, but you can also take x and y to be equal. X equals to 4 equals to y. So this is 1 is to 1 and this is also 1 is to 1. So they can also be equal. So D, perfect. They can also be equal in values. That's why, right? There is not given, they're distinct positive integers. So D. Okay, let's try this one. Okay. D 500 is the answer. Yeah, right. So what you can see that Peter, in this case, the entire money for the Peter, Jacob, and Ron. We know the ratio of the Peter and Jacob is 2 is to 3. So 2 is to 3. And then it's given for the Jacob and Ron is 2 is to 5. Now, if we have to you know, compare all the three, then the Jacob's part needs to be equal, which means he needs to be multiplied by 2 in the above and 3 in there on, and hence here also we need to work out the same. So the combined ratio would be 4 is to, that is 6 for both of it, and then 10, right? So 3 we multiply by 2, and for here 2 we multiply by 3, so that's, sorry, 15. So 4 is to 6 is to 15. That's what, we need to, we'll get as the combined ratio. Now what is given if Peter has 80? So this 4 parts actually corresponds to 80, which means it's 20 times more. So 6 would cover to 6 into 20, because it's, 4 into 20 will give you 80. So 6 into 20 would be 120, and 5 into 20 would be a 300. So hence we can say that total money with all three of them would be 300 and another 200. That's 500, which is option D. Perfect. Right. So that'll turn out to be option D. 500 for both of them, which is the right answer. Perfect. Okay. Great. Great going. Let's go into the next one. 500 is right. Okay. Now, certain questions regarding the time, speed, distance. Okay. Now, when we talk of the average speed, basically, now before we actually go into the TSD, there are basically three relationships that we need to keep in mind. First is whenever, as I say, the only three quantities we'll discuss with distance, speed, and time. Now, first, when distance is constant, how speed varies with time. As we see, to cover the same distance, if it increase the speed, the time would increase. It's like, let's say, if we have to travel, for example, from let's say Thane to CST. If you take a slow train, if you take a slow local, it's definitely going to take you more, around 1 hour or so. But if you take a fast one, it'll just make you reach in another 40 minutes, 40, 45 minutes. So between the two same destinations, if you take a faster one, you reach earlier, whereas you take a slower one, you take more time. So to cover the same distance, the speed increases, the time would decrease, and hence the inverse relation. Second case, when speed is constant, distance and time. As you know, at the same speed, if you're traveling at the same speed, you travel more distance, you'll take more time. So let's say at 60 miles an hour, if you drive from Mumbai to Pune, it'll take you more time to cover that distance as compared to, if you drive on from Mumbai to Goa. Of course, Goa is much more farther than Pune, and you're not increasing on your speed, you're driving safe. So therefore, you're going to take more time, to travel to Goa as compared to Pune. So hence the direct relationship. And the thirdly, when time is constant, when t is constant, speed and distance. In the same time, the one who drives faster would cover more distance. So someone who's driving to Pune in a Nano would definitely take more time as compared to someone who's driving in a BMW, right? So that a faster speed, that same time you cover more distance. So these are the three fundamental relationships that you have to keep in mind, and hence that will actually transform to that simple formula that speed equals to distance upon time, distance equals to speed into time, and time would be equal to distance upon speed. Basically, it's just a play of these three formulas, nothing else, the whole chapter of that. Now, besides this, you should also be aware of the conversion, for minutes and seconds from hours, you would know. That 1 hour would correspond to 60 minutes and would correspond to 60 into 60, that is 3600 seconds. What you need to remember, usually because it's a US test, it's an American test, so you need to be a little more familiar with the units conversion, the one which is followed in US as compared to in India. We stick to kilometers for all the distance one, whereas US follows miles. So I need to know certain conversions, in terms of miles and kilometers and the other units as well that has been very commonly followed. So I'll just write down a quick conversion only of the distance because time and it would be easy. So hence you can transform the speeds in that one, because generally distance would be whenever you have a questions of about people crossing each other, the distance, let's say a man crossing another man or a car crossing a truck or so, would be expressed in meters. Time taken to cross each other would be in seconds, where the speed would be given in miles per hour. So there will be some kind of a disconnect between the units, so you need to convert them, right, depending on what the distance and times are being expressed into. So for the distance conversion, 1 mile is approximately, you know, 1.6 kilometers. So 1 mile runs around 1.6 kilometers, which is approximately 1600 meters. As we know, 1 kilometer is 1000 meters. Now, 1 mile is also in yards, 1760 yards. You do follow the units of yards in there. Now, what you observe that yard is a unit very close to meters, because 1 mile is 1600 meters and it's 1760 yards. So you can say that you know around 1 yard is point 0.9 something meters. So you will never have a conversion from meters to yards because they are more or less the same comparable units. What you will have is either miles to meters or miles to yards, majorly in yards. Okay, that would be preferred, or from kilometers to meters, and that one, which is 1000. Also, if you look at this, 1 yard actually is equal to 3 feet. So 3 feet makes a yard. That's the basic conversion that you have. 1 feet actually measures 12 inches, so 12 threes are 36 inches. So sometimes you need to convert from yards to inches as well. Okay, as you know, this is the basic one. So 1 foot is 12 inches. Okay, so these are some very common conversions that you will come across. For the time, and hence you can do that well. So you can very well work it out. Like if I have to convert, let's say from 1 mile per hour to how many meters per second. So we know that a mile would convert to meters as 1600. Hours would convert to second into 3600, which is 16 upon 36 goes on 4 by 9 times. Now, instead of remembering this as 1 mile per hour is 4 by 9 meters per second, you can cross multiply and say 9 miles per hour is 4 meters per second. Yeah. So something that is more in the integers and would be easier to work. So if then value, which are mostly in the multiples of 9, you can just simply convert into the multiples of 4. So if you say what is 45 miles per hour in terms of meters per second, so that's 9 into 5, so 4 fives are, that's 20 meters per second. Okay, that becomes very quick. Okay, so that's one thing you would see other than just the concept here on TSD, that they will ask you questions which will also involve the conversions on the units, and hence be a little more careful on that. I'm sorry. Now let's see the questions on the case of average speed. Try this out and then we'll discuss. Okay. So what is the formula that I'll use here? 50 would be if you are taking it as an arithmetic mean, right? So when you talk of the average speed, the basic formula is total distance divided by the total time. Okay, now this is the universal formula which will work for every possible question. Now, if there are certain special cases like when time is constant, which means a person is traveling for the same time interval. Okay, so let's say he traveled from A to B and B to C for same t hours at a speed of x miles per hour and y miles per hour. In that case, his average speed is simply x plus y on 2. That becomes the arithmetic mean. And case 2, when he's traveling for same constant distance, that means he travels, you know, from A to B and B to C, the same distance d at the speed x miles per hour, y miles per hour. Or it's also a very common case of a to and fro from A to B at x and then from B to A at y. Then his average speed is 2xy the whole divided by x plus 1. So you just need to identify which type is this. Okay. Is this the same distance or the same time? And then accordingly use the formula. So in this case, we saw he's traveling A to B and return. So that is the case of to and fro. Right. So this is the case where, D is constant. So therefore, the average speed in this case would work out to be 2 into x, which is 40, into y, 60, the whole divided by 40 plus 60, which is 100. So 2 into 40 into 60 on 100. The zeros go, and this is 24 into 2, 48. So hence the average speed is 48. Right? So it's going to be 48 miles per hour. Right? So this will be the average speed. Okay. So these are the just two special cases that we need to check, and hence the answer accordingly. Right? A very easy type. Yeah. Turns out to be 48. Okay. Now let's look at this question. Just use the concept carefully. Yeah, okay, let's check. 2.25 is correct. But who's faster of the two? The Nairobi or the Bogota? Which one? The first or the second guy? The second one, right? Okay, perfect. Now, yeah, perfect. So what we can use here is this the simple concept of average speed. Now here, neither the distance nor the time is constant, so we cannot use the shortcuts. So we need to adapt to the normal routine, the normal form. So it says the first one fourth and then the three fourth of the distance. Let's do for the Nairobi. So let's call this as d by 4. Don't involve fractions as much as you can. And then you can say this is 3d at 15 and at 30. So distance are d and 3d. That's one fourth and three fourth of the total of 4d. Instead of taking d and d by 4 and 3d by 4 and 15 and 20, then the average speed would simply be d plus 3d. That's a total distance divided by d by 15 plus 3d by 30, right? So that's 4d. That's d common here, as you see. It's 1 by 15 plus 1 by 10. So the d gets cancelled out. 15 and 10 LCM is 30. So 4 into 30 divided by, the LCM that will have gonna be 5. So 5, 6 times 30, and that's 24 miles per hour, right? Perfect. Okay, that's for the Nairobi. Now, it's the same thing that we need to do for the other guy, Bogota. For him, it's one fourth of the time and three fourth of the time, which is t and 3t at 15 and 30. Okay. Then his average speed is total distance is speed into time plus 30 into 3t, that is 90t, the whole divided by 40 3t, which I'll, okay, let me just write this clearly. This is t plus 3t, which is 40. So 105t over 40. The t gets cancelled. It's 105 by 4, which is 26.25. See, it's on 4, right? So it cannot be in 0.333 or 666 recurring. So that's 26.25. So we saw that we got the first one as 24 and the second as 26.25, right? And hence the difference is 2.25. So Ogata's average speed is 2.25 more than that. Okay, perfect. That makes sense. Done. Now let's go to the next one. It's a concept of relative speed. Just use it properly. Check this one. Okay, so what is the answer? B, 10:30. Okay, so it's given that Joe Snow starts from A at the speed of, let's just place A, 60 miles at 5 a.m. Always take the time when the other guy starts, so that's at 5:30. So let's take an event at 5:30 when Nick, starts from here. So let's say Joe Snow would be somewhere here at that point of time. He had traveled only for half an hour, so therefore the difference is 330 miles. When Ned Stark starts from here, the time is 5:30. It's always for the last person to start, which is at 5:30. So, in order to find time that Ned would take to meet Joe, it's simply the gap between them when the last guy starts, depending on their divided by the relative speed. So, in this case, the gap is 30. Speeds are 60 and 90. So, that's 90 minus 60, right? Which is 30 on 30. That is 1 hour. Okay. But then we are not interested in this one that he will meet after how much time. So the question is, after how many hours Ned Stark would meet Josh? That will be after 1 hour. Okay, 1 hour after the starts. So that's 1 hour after 5:30, which is 6:30 a.m. Now, at 6:30, they both would be somewhere here. Let's say Joe and Ned. He traveled this much. He ended up traveling this. Now, at some point, N has to have a lead of another 120 miles. Now, in order to cover 120 miles at the same relative speed of 90 minus 60, which is 120 by 30, it'll take another 4 hours, right? Because he's adding only 30 more hours in that case. So 4 hours after 6:30. So the time when he will be, that is 6:30 plus another 4 hours, which is going to be 10:30. So hence he would be 130 miles ahead. Okay, 120 miles ahead at the time of 10:30 a.m. Uh, Shantanu, yes, you can work with the options, but in fact, it is just a one straight calculation. See, because with the option, if the option E is the last one as the answer, then you will end up wasting time trying out the first four options. So it's the same thing that you can say, okay, as a one so when net starts, okay, Jack, say Joe Snow is here. At the end, I want Ned to be somewhere here, which is 120. So he needs to first of all travel 30 miles plus another 120. So Ned has to cover a total distance of 30. And let's say he is traveling at 60, Ned is traveling at 90. So imagine if I make him, stationary, which is subtracting 60. Slow both of down them by 60, which is what basically how the relative speeds are calculated. Okay, given the slower one was stationary, what speed the faster one would cross. So if Joe would be 0, he'll just stand there. Then Ned has to cover the 30 miles gap to meet him and then add another 120. So total distance to be traveled is 150 divided by 30, which is 5 hours. It's 5 hours after 5:30. So therefore the time would be 5:30 plus another 5 hours, which is 10:30. That's it. One straight calculation. That's it. All you need to do. Nothing else. So what you need to imagine is if the slower one would be stationary and the faster one is traveling at relative speed, then what is the overall scenario? So Ned has to first cover the 30 miles because Joe is ahead of Ned by 30 and add another 120. So total distance to be covered 150 at a relative speed of 30. So hence he is going to take 5 hours. Okay, that's all. So you don't need to again check. It's just one simple calculation to find time. Becomes easy. Right. So this is one way of handling the relative speed problems, assuming the slower guy to be stationary and faster traveling at the relative speeds, and always take in the time of the last guy who starts. Okay. Now let's look at the next one. Try this out. 100 is correct. So what we can imagine, in fact, sorry, just going back. Uh, Here we can see that, let's say they start from these 2 points, and somewhere they met here in between. That's a meeting. So this train traveling at 60 miles and this train traveling at 40, this is the point of intersection. So let's see if I would have just reversed the whole situation 1 hour before. It's just like you replay that. So this train would be here traveling in this direction. So in 1 hour before the meeting, the first train would have covered 60 miles in 1 hour. The second one would have traveled 40 miles in the same hour, which means they just now traveled and met here. So the original gap between them would have been 60 plus 40, which is 100 miles. So hence you would find that the original gap between them should have been 100 miles. Yeah, perfect. That's the same thing that you need to do. Just see, okay, when they've met and reverse it. Just replay back and see how much distance they would have traveled in the last 1 hour, and that would be the actual gap between both of them. That's right. That's it. Okay. Now, before this was actually supposed to be the last question for the class. Okay. Now, there's just one extra question that I have. Okay. Before you go to this one, okay, I'll just take a blank screen and explain that to you. This is a little challenging one, uh, tough one, you can say. Okay, so be careful. Get me the right answer. You're gonna get only one shot. Okay, just explain you the whole situation. Okay, it's a word problem again. So let's say every day, John, okay, would walk from his school to his home, a distance of D, right? Taking some time. On one day, he met his, you know, he ended up meeting a friend, Julie. Okay, let's say where she stays right midway. You know, her house is exactly midway between the distance that he walks. Right. So that's the Julie's house. Okay, that you can call it as, his drop point. So I have already used H, so call this as the drop point for Julie. So on that day, and so Julie also taking her transport, she ended up actually missing on it. And then let's say there's some situation where she's walking up. So John and Julie, they walked the same distance. John dropped her at her home, okay, and without any time lag, he continued walking towards his home. So on the day when he was walking with Julie, he walked at 3/4 of his original speed, right? So since normally he would walk in, so he walks at his normal speed every day, walking a total distance and taking some time. On that day, he accompanied Julie, so he was walking slightly slower. Of course, they were talking and having a good time. So he walked at 3/4 of the speed of his original speed, normally what he would walk, dropped her, at D and continued walking further on. Okay, no time delay. And okay, so the question is, and at what speed should he cover the later half of the distance in order to reach home, okay, in time? So he has to reach home in time. So the first half he walked at a slower speed. So the next one definitely he has to walk a little faster. So what is the speed he should walk the second half of the distance so that he would reach home in time? Okay, please understand the whole construct. Okay, if there's any confusion, please ask me before you start solving. So the first part is John would always walk from his school to home. So they say this is school and this is his home, a total distance at some certain speed, taking the same time every day. One day he ended up meeting Julie, so Julie accompanied him. So he walked at a little slower speed, three-fourths of his normal speed, dropped her, at her place, which is exactly midway on the same route, and continued walking. Now, at what speed should he walk the remaining distance? Of course, the increased speed so that he still reaches home in time. Right? No, no, no. 1.55, no. 1.5, no. Sorry. 1.5? 5 or 1.5? 1.5 that he walks every day. 1.5. Yeah. 1.5. Yeah, he's correct. Right. Perfect. Good, guys. Yeah. Awesome. So there are actually many ways you can look at this. The simplest would be just to take some numbers. So let me say I'll take the S value as 4. He's walking at 4 miles per hour. So that the reduced speed 3 by 4 is 3. Let's say the distance is also 2 and 2. Total distance is also 4. So time taking is 1 hour. So in this case, using the numbers, I'm just using the numbers here instead of formulating an algebraic equation. So he covered a total distance of 2 in this 3. So he took 2/3 of an hour here, time taken. Okay, so the remaining distance 2, he should cover in the leftover 1/3 because the total time taken should be 1 hour and the time left is only 1 minus 2/3, which is 1/3. So he needs to cover the remaining distance 2 at the speed of 1 by 3, which means he has to cover in 6 miles per hour. Right? This is a new speed as a fraction of the old, which is 4. So 6 by 4, which is 1.5. Right? So this is what you can use directly, assuming distance to be 2 and 2. Okay? So take S as 4. 3/4 would be 3. Time taken is 2/3. Left is 1/3. So remaining distance of 2 miles to be covered at 1/3, which is 6 miles. And hence the speed as a fraction of the original 6 by 4, which is 1.5. Okay, that is taking the numbers. In fact, if you use ratios, which is a much faster way of looking at the same question, okay, that's what basically I try to use much of it. And that is what the best shortcuts that you have for this one. So hence the speed reduces to 3/4, the time increases to 4/3, which is 1/3 extra. Okay, so I'll see is speed becomes 3/4, time became 4/3. So he took 1/3 extra. Now, as he took 1/3 extra, he has to compensate in the next half because t is constant. So he should take 1/3 less. 1/3 less, that means he should take only 2/3 of the time. And if the time should be 2/3, that means the speed should be 3 by 2 and hence 1.5. Right? That would give you the answer directly. Okay, perfect. Good job. All right. All right. So that brings us to the end of this session, actually, that we had in the end. So in the next session, then we will start with the second part of it. Okay. We have already done that one. So that would be focusing more on the algebra inequalities one that we have. Okay. Acha. Okay. The last part, or I'll say it like that. So when we say again, look at it like this. The distance is constant. Okay, because he's traveling the same distance, say d. So d is same. S inversely proportional to t. That is the logic. So speed, and time. Speed became 3/4. That means time increased to 4/3. That means he took 1/3 extra. So this 1/3 extra he needs to compensate in the second time, which means he should take only 2/3 of the time. As he should reduce his time to 2/3, which means his speed should go up to 3/2, which is what we are looking at. So that should be his new speed. Is that clear? Right? So distance is constant. I can directly use the idea of speed as inversely proportional to time. 3/4, 4/3, 1/3 extra. So next time compensate 1/3 should be 2/3, and hence they should be the inverse of that again, 3/2. Direct. No need to write anything. It's just, hardly 10 seconds to calculate that box. Okay. All right, guys. So in the next session, I'll just inform, in fact, either Samyak or Shashank about what is going to be covered in the next session in advance and what you need to read before to, that to come through that one. I'll update on that. Okay. So this one covers the basically the ratios, percentages, and the time speed distance. So next time we're gonna do maybe some question related to allegations and mixtures, and also with the rate and work. I'll let you know what are the topics that we would cover in the next session. Okay. All right, guys. Uh, that will be posted on your WhatsApp group. I'll tell Samyak to do that, and then accordingly you can just have a bit of pre-read and come and let you know. As Samyak has posted the query, if it's we can keep the class in the morning, that is from 10 to 12, instead of keeping it in the evening, which is 5 to 7, like say 5 to 7 types. So I'm just gonna check it, with my concerned authority, and if your college permits, then I don't have any issues doing it in the morning part as well. Okay, yeah, you guys have lectures in the evening, so some of you might be missing. Sunday morning will also do, right? Gauri, okay. Just post that if there are any issues about the login credentials and all that, do let us know, no? Because then we'll work it out then on that one. So if you try to work it out on the Saturday Sunday thing, that is better, right? Sunday mornings or something like that. Weekends, also on weekends or something. Okay. Yeah, I'll let you know. I'll just discuss out the entire schedule, when we need to start with the test, when you should be ready. I'll just share the entire study plan with you guys. So don't worry about that. I'm gonna do that. I would just check with the college people first. Of course, this is not my decision or purely yours. No, it has to get approved from my concerned department as well as from your college. So I'll just pass on the message, and we will check if it's convenient to everyone. We'll just decide on something that is convenient for everybody, not at, some people should be at a loss of it. Okay. So I'll just pass on the message and we'll see what needs to be done. At the end, it would be the decision of the concerned authorities. Okay. Okay, guys. Let's check. So I'll connect with you on the next week, same time, Monday, and then we'll cover up. We'll start with a new session and then cover on that as well. Okay. Till then, goodbye, guys. Take care. That was fun. And I'll see you next week then. Right. Bye. Take care. Stay safe.